Hello everybody, it's Miss Fincham and we'll be continuing Unit 1 by covering the topic 4.3, Soil Composition and Properties. In topic 4.2, we focused on what soil is. Here we'll focus on the different properties that give soil its fertility or its ability to support plant growth. Thank you to Jordan Smeeds for the slides and notes we use in class. Our objectives today are to be able to describe the similarities and differences between properties of different soil types. This means the knowledge we need in order to do that is that all soils are made up of sand, silt, and clay, and the different sizes of these particles determine how the soil holds water and nutrients. We will learn how to classify different soils based on their texture or the percentage of silt, sand, and clay. We will also need to understand the different factors that affect water holding capacity of a soil. Finally, we will learn about some of the basic tests that can be done to measure the fertility of a soil or how well it is able to support plant growth. Our suggested science practice is to be able to describe an aspect of a research method or an investigation. In video 4.2, we talked about how soil is made up of lots of different things, such as rock fragments like sandstone and clay, humus or organic matter, or even water or air. In this video, we'll be focusing on the geological or the rock-based portions of the soil. When rock gets weathered, it gets broken down into tiny little particles, and we call those particles sand, silt, and clay. These particles have different sizes, and their size determines a lot of the characteristics of a soil. When we talk about a soil's texture, or what it feels like, what we're really talking about is the percentage of sand, silt, and clay that are present. Since the individual sand particles are so big, the space between them, or the pores, are also really big. We can see that if we look over at this diagram here of the sand, we can see how large these individual sand particles are, which means that the space in between them, the pores, is also going to be very large. Clay, on the other hand, is a very small particle that packs together very densely. The pores between clay particles are very, very small when we compare them to those large pores within sand. The amount of pore space in a soil is referred to as its porosity. The more sand in a soil, the more porous it is. This makes it easier for air and water to enter the soil, which is vital for plants since the roots need to take in both water and oxygen in order to survive. A soil texture chart helps us to determine the type of soil that is present. All soils are made up of sand, silt, and clay, but pretty much no soil is just pure sand, pure silt, or pure clay. All soils contain some mixture of the three, so because the percentages of sand, silt, and clay determine the texture and the porosity, it is the main way that we classify different types of soils. If we wanted to calculate the texture of a soil sample, we could get a sample of the soil, then set it in a jar of water and let it settle out overnight because the different particles have different densities. What we will be left with in the morning is a layer of sand, silt, and clay that we can then measure to determine the percentage of each. If we look at the sample we have here in the mason jar on the screen, this is going to be 45% sand, 35% silt, and 20% clay. Using a soil texture chart, we would see that the percentages line up here in the loam category. That is because we have 45% sand, and if we follow this out here, we have 35% silt, and we'd have 20% clay. So this soil would be categorized as a loam soil. Here are some tips for how you can use a texture chart to determine the classification of a soil. The first tip is that we will always start at the bottom with the percentage of sand, then move out to a point where the sand and the silt meet. In this example, we have moved from 40% sand to the point where it meets with the silt, and that is 40% silt. Then we're going to go straight over to determine the percentage of clay, and that is 20%. You don't want to go from 40% sand and then go straight over to silt. because 40 plus 80 is 120, and you can't have 120% of anything in the soil. This is the key to determine if you did things correctly, because the last rule is to make sure that it adds up to 100%. If it doesn't add up to 100%, you did not do it right. If it does add up to 100%, then chances are you probably did. So let's practice by trying to find the percentage of sand, silt, and clay of this blue circle on the screen. I'll give you just a moment to do that. How did you do? Did it equal 100? Starting at the sand, we can see that it is 30% sand. And remember, we want to go out to the percentage of silt on a diagonal, which would be at 20%. And then we want to go straight over to find the percentage of clay, and that's 50%. This means we have 30, 20, 50 for each of the soil particles. Now we will take a look at how porosity relates to water movement through soil in a little more depth. Remember that porosity is the pore space between soil particles, so the more porous the soil is, the more easily water enters it. If a soil is more porous, then it is also more permeable. Permeability just refers to water's ability to drain through a soil. That means that water can drain through really easily if there are large pore space and high porosity. On the other hand, if a soil is more permeable, that means it doesn't hold water as well. We would say it has a lower water holding capacity. Porosity and permeability have an inverse relationship with holding capacity, meaning the more porous and sandy your soil is, the less water it can hold on to. This also means that the more clay-based your soil is, the less porosity and permeability it has, giving it a higher holding capacity. What does this mean for plants? Plants need a balance between permeability and water holding capacity. If they need some degree of porosity so that oxygen and water can enter the soil and get to the roots. If the soil gets too sandy or too porous, then it has really high permeability and water just drains straight through it before the roots have a chance to access it. If the soil is too clay dominated though, then the soil doesn't really drain water at all, and the roots either won't get access because the water cannot even penetrate the soil, or the water will penetrate the soil, but then it will stay there and suffocate the plant roots because they won't get access to the oxygen that they need. The ideal state for plants is a nice medium balance between the permeability that comes with sand and the water holding capacity that comes with clay, and that is a loam, which is roughly a 40-40-20 mix of sand, silt, and clay. This is really an ideal soil for many plants because it allows water and oxygen to enter the soil and drain through at a moderate rate that prevents waterlogging but does not dry the soil out too quickly. If we look at the diagram here, we can see that the sandy loam, which is again a nice mixture of sand and clay with some silt, is going to allow water to move in. It is going to allow the water to be held, giving it a moderate water holding capacity, but it is also going to allow it to drain through. If we're looking at a more clay dominated soil, the drainage is very slow and it becomes waterlogged, which can suffocate plant roots. If we have a sand dominated soil, the drainage is too rapid, so the porosity is too high and the holding capacity is too low. A sandy loam is a nice happy medium that really allows plants the proper drainage, but also the proper access to water. There are also soil properties that affect soil fertility or the ability of soil to support plant growth. Since plants need nutrients and water from the soil, we'll look at the factors that affect each of these. Some of the most important plant nutrients that are found in the soil are nitrogen, phosphorus, magnesium, calcium, and potassium. Factors that increase soil nutrients include more organic matter, which gets broken down by decomposers and turned into humus, which releases these nutrients for plants. Humus also improves the ability of soil to hold water, though, so it is an especially critical component of soil. Clay, which is negatively charged in Soil nutrients, which are positively charged, will bind the clay particles, which helps them to remain in the soil and available for the plants. Finally, there are bases like calcium carbonate, which is given off by limestone, that helps buffer or neutralize the pH of soil so that the soil doesn't become too acidic. One of the main factors that decreases soil nutrients is acidity. Soil that is too acidic leaches nutrients or loses them very easily when rain or other water washes through the soil. Excessive farming of the same crops from year to year can also deplete the soil because the plants use up the nutrients. If no organic matter is returned to the soil, and if the topsoil is eroded heavily from repeated tilling or compaction by farm equipment, then nutrients will be lost from the soil at an even faster rate. Water is also very important to soil fertility. If soil is well aerated, meaning that it has a lot of channels through it that come with organisms like earthworms burrowing through it, that will allow the soil to hold more water and more air. The addition of organic matter or compost or humus can also act like a moisturizing layer that prevents evaporation loss from the soil. That will help it retain more water. Finally, we have root structures in soils. If there are native plants available that have deep roots, this will help retain moisture in the soil and prevent it from drying out. Factors that dry out soil include the compaction of soil, since there are fewer pores to hold moisture, as well as topsoil erosion and the loss of root structure. The last thing we'll discuss today is soil quality tests. We will be doing many of these in class, but I want you to have an idea of what they are before we get to that. Soil texture is just a measure of the percentage of sand, silt, and clay that can be found just by letting a soil sample settle out in a jar of water overnight, and then measuring the depths of the different layers of sand, silt, and clay. This can give you an idea of what kind of soil you have, so you can classify it as a loam or a sandy loam, and it can also tell you how porous or permeable the soil may be. However, if you want to measure the permeability directly, that is a relatively easy thing to do by just setting up a plastic column, filling it with your soil sample, and then measuring the amount of time it takes for a given volume of water to drain through your sample. Then you would want to do this relative to a control. This can indicate if the soil is too permeable or if it retains water for a more optimal amount of time, which will allow plant roots to access it. Then we have pH, which is the most basic chemical test you can do on a soil sample. You can just mix up a soil sample with some water, dip in a pH test strip, and this will give you an idea of the measure of the H positive or hydrogen ion concentrations in the sample. The more acidic a soil is, generally the less optimal it is for plant growth, since acidic soil can leach nutrients away very easily. We can also use color, which is a really simple test. By taking a sample of soil, you can compare that to a color chart that you can find in something called a soil book, and this will give you an idea of how much humus or decomposed organic matter there is in the soil. Remember that the darker the soil, the more humus, and generally the better that the soil will hold nutrients and water that's needed for plant growth. Finally, we can measure nutrient levels directly with various chemical tests that will measure nitrogen sources like ammonium and nitrates, and phosphorus sources like phosphates, since they are key limiting nutrients for plant growth. The more of these nutrients generally, the better soil can support plant growth. Our practice suggested skill for topic 4.3 is to describe an aspect of a research method or an experiment. What I want you to do is try to identify and describe one test that has been mentioned in the notes today that can be conducted on a soil sample, and then explain how the results of that test could allow you to give advice to a farmer who's trying to grow crops in that soil. So you are giving the advice to a farmer about the soil that you have ran this test on. When you finish, please take a picture of your notes and upload them into Canvas under 4.3 Soil Composition and Properties.